Okay, so without wasting much of our time, so we are still under cryptographic CTF challenges. So the tool which we are using is sokonalysis, which is the Cipher toolkit built for all skill levels. Okay, so this repository is still private. If you want a copy of this tool, you can simply drop down your email or username for GitHub. Okay, so basically this particular tool, you can build it or install it on your Windows machine using these commands. Then again, you can download or build this particular tool in Linux. Okay, so for the first time use, you'll be prompted to agree to the user terms, which we are saying this tool is for educational and ethical use only. Do not use this software for any malicious, unauthorized, or illegal purposes. Do you agree to these terms? If you agree, just say yes. Okay, so if you don't agree, we all know we cannot use the tool. Okay. Yeah, so this is the main menu. Now this tool is focused on 3 levels or phases. So the first phase is the university level. So under the university level, it's meant to help out students to calculate basic cryptographic algorithms such as RSA in solving their exam questions. It can be assignments or any other related tasks which they might be given. Okay, so demonstrating this will be shown nicely when we do this level. Then we come to CTF level, which is capture the flag challenges level, whereby we utilize this particular tool to solve a particular challenge until we get the flag, minus us requiring to use multiple resources. Okay, no wonder we are calling it a Cipher toolkit built for skill levels, or all-in-one Cipher toolkit. Okay, so the last level is what we're calling the advanced level, for which we haven't yet started implementing, so stay tuned for more updates. So supported algorithms for now, we have symmetric, asymmetric hashing, capture the flag, and advanced cryptography, and these algorithms which you can see are the ones supported for now. So today's challenge, we are doing a challenge on CyberTalents which is called 0verl4p. Okay, so the category, we know it's cryptography, so people tried this out 70, then who solved this 24, including me. Okay, so even you, as you are watching, you're going to solve this one, so the numbers will be increasing. So the whole idea for me to actually demonstrate this tool is we are utilizing a challenge which is not yet solved, or which has no write-up available, so that you might get a chance to watch this particular video. So this is rated as medium, so let's see what's happening. So the challenge description is: my friends are texting me using RSA to encrypt the messages, but some expert told me that there is a bad mistake in the implementation. Can you figure out what it is? Okay, so the first thing, we need to click on this particular link. Okay, so once we click on that link, we need to just say save. It's more like we are downloading it. So in my case, I'm downloading this file in a folder called crypto, so it's called 0verl4p. So I just need to say unzip or extract here. Okay, so once I say extract here, we can see under 0verl4p we have this the source code which we are used. We can check out this. It's more like they're encrypting a flag using these bytes, so I don't want to talk much today on what's happening. Okay, so let's just understand how we can utilize sokonalysis to actually decrypt this. Okay, so let's check out the output. So this is the output which we are given. We have a lot of things here. Okay, a lot of things. So take note, we have this key which is called my private key. Okay, let me just copy this and so on. So let me just open up sokonalysis so that we get started. So to run sokonalysis, just say / then sokonalysis. So today we are not prompted the user agreement because we already agreed. So remember, we are doing capture the flag challenges. I'll say option number 6. Then here we are dealing with RSA. Okay, so I'll say 1. Then we have a lot of options, as I've said, but always we need to understand what we are dealing with. So if we look at this output.txt, we have a private key, which is this, and we have this one, which is written keys. So if you pay much attention, it's more like we have a longer key, comma, a smaller key. So let me just do this so that maybe we can see. Okay, so it's more like we have a larger key. By the way, let me just do this. You don't want to waste time here. Let me just open terminal here, and then we'll say cut the output.txt, then we grep or we filter out this particular thing, which we are calling my private key for now. I just want to show you something. So that's my private key. Okay, so if we filter out, which is called keys, because they I'm unable to look for things nicely. So if you look at these keys, understand the way they are. It's more like you have a key, then at some point it's stopping, then they're saying comma something. So this is more like n, comma e. So we have a lot of n's and comma e's. So this is the type of RSA challenge you are dealing with. So coming back to sokonalysis, under the options, we can see we have this option, which is option number 20, which is saying common modulus. Okay, decrypt C, which is the cipher, with D, which is the private key, where N is identical using multiple E's. So let's validate if it's correct. So I don't want to use this, by the way. Where is my okay? So at first I grabbed out my private key. We can see we have a private key, meaning this is our D, the private key. Then they are telling us the N is identical. So let's just see the pattern here. So if we look at N is starting with 18 all the way to 81, so it ends there. Again, you can see N is starting at 18 all the way to 81. Same applies to this one, so N is identical. So we can go with option number 20, which is common modulus decrypt C with D, where N is identical using multiple E's. So we can say 20. Okay, so once we do that, say 20, they are telling us to enter N. So we already know N is identical, so it's in our best interest to just enter it once. So this is the value for N. You can just say copy. We don't want to waste time again, so let me just do this. So that's our N pasted. Then enter the value for D, which was the private exponent. So just clear, bring back my private key, which is D, and then I'll just copy, shift Control C. No, we can just use the normal one, which is like this, paste or copy. Okay, so now we need to enter the ciphertext. So what did they say about it? So they're telling us encrypted data, so that's the ciphertext. So let me just grep this, because last time I was having issues using that option. Wonder I'm now using grep. So we can grep out this guy. No, all right, just a minute. We can grep, let me just say encrypted, because I thought I had copied the thing. So encrypted data is starting at 17 all the way to 2, not just a 0, like this. So copy, make sure I've copied that, then make sure we paste, enter. So now they're telling us enter public exponent, which is E, used to recover phi. So phi is more like the value which is needed to find the value for D, because we say the inverse of E and D is supposed to be equivalent to 1, the Euclidean theory. So let's just enter the value of E. So the default value of E is this value. Now if we go back to our code, where is that code? Okay, I'm sure it's in here, output, and then this is the source code. So if we go back to our source code, you can see E is the default value, which is 65537. So we need that. So if we just press enter, it will be the default, or we can just type. It says 65537. Okay, correct. Just validate. So how many E's are you entering? So E dash I, meaning I is incrementing. It can start at 1, 2, 3. So how many of those are you entering? So if we come back where it's written keys, we can count from here. Okay, so let's start counting here. We are not sure, so we say 1. Okay, we see where there's a gap again. 2, another gap, come at 3, another gap, 4, another gap, 5, another gap, 6, and then where's another gap, which is this 7, and another gap 8, another gap 9, and then the last one, which is 10. So we are entering 10 values. Okay, so power just cut. Let me just pause this. Okay, so sorry for that. Power is back now. So here we need to start entering the values. So we said we're entering 10 values. Okay, so what I'll do is that I'll start from the first. So we can see here, this is our first E. So I'm going to copy this. So I'll be doing this manual copy so that we see. So I say copy, then paste, enter. We come to the next one, which is this, the one ending with 97. So we paste. Then we come to the third one, just scroll down a bit. We have this other one, which is ending with 27. So we paste. And then fourth one, let's go 91, ending with 91, by the way. So we paste. And then we look for another thing which is ending with 33. So we copy this, we paste. And then what other thing do we need? Ending with 53. We copy, paste. Then the next one is this guy, though it's more like it's hidden, but we can see you. Okay, so it's ending with 97. We paste. And then let's go down. We have this one ending with 59. So make sure we don't miss anything. So we are just remaining with 2 more. So we have this one ending with 49, and the last one, if we are not mistaken, which is just this one ending with 03. Okay, let's hope everything is accurate so that we get our flag. How come it's telling me flag, but I cannot see any flag? Okay, so what has went wrong? So let me just pause the video. I redo all the entering so that you don't waste time. I'm sure I've made a mistake somewhere, because it's saying the K which has been found is this. Let me see if I've entered everything. We have N, which is 18 whatsoever. You might find you've entered the same N and D. So it's ending with 81. So D is ending with what? 81. Is it? No, it's different. Okay. So we come to our cipher text. It's ending with that number. So we said 10. Okay, let me just repeat this. So I'm pausing the video. Where is that? Okay, so I've noted the problem. It's because this my private key is having n, okay, is having n. You see we have a comma. This is n comma d. Remember, a private key is n comma d and a public key is n comma e. So we had missed out this part, so it was failing to get the actual flag because we are copying everything as my private key. So this is the value for n. Okay, so let's just now repeat this step. So what to do, go with option number 6, which is capture the flag. Then again we repeat RSA, which is option 1. Then we are using common modulus where decrypting C with the D where n is identical and multiple is. So we are going to say 20. Then when they tell us to enter n, I'm going to enter that value for n, which is starting at 18. Now if you can notice this, we are saying n comma d, so meaning this is the private key, which is now our d. So that was the mistake which we made at first. No wonder we are getting something else. So when you come to the ciphertext, we are getting now this actual ciphertext. So everything we did was actually right. It's just the issue of the d. Okay, so here you paste the ciphertext which you have been given. So use the default value for E, which is 65537. Then the value we're entering for E was 10. Then we just need to start pasting each and every value for E. So we'll start at first again, following the sequencing. So if we look at this first value ending with 41, that's our first E. So we're going to paste that value. Then we come to the second one. So if we scroll down, we have this one which is having 97. Okay, and then after we do that, we have the third one which is having 27. So we need to be extra careful. We might even blame the two. Instead, this is just our human error. Okay, so that's the bad part of capturing the flags. We are given a lot of data such as this one. You make a simple mistake, again you start counter checking each and every mistake you made. Okay, it requires effort, time, but all in all, without a tool it's harder than this. No wonder we are using these methods. We come up with a tool which can reduce that manual work. Okay, so we continue. We are almost there. So we have this one. So here I'm just going faster because the video isn't meant to be this long. Okay, so we come to 8, number 8, our 8th E. Okay, make sure we copy everything in order, paste. So we have 2 more to go, which is this and the last guy. Then we have our flag, if no mistake again. If we don't have the flag, I won't post this video, I'll just delete it. What's the whole point? Embarrassing myself. Okay, we have the flag. So the flag has been found, which is flag no mistakes with RIC. So they were just playing with us, no mistakes with RIC, and they know that if we just make a single mistake, meaning we won't get the flag. So you can see we found the value for phi, which is this particular value. So we know for us to find the value for D, I was saying we need to have E comma D. Now the inverse for E comma D is what gives us E comma phi is the inverse which gives us D. So it's more like we utilized the D which we pasted for us to we pasted E and D. Okay, or I'm saying E and phi for us to brute force this or E and D in our case for us to get the value for phi. Okay, so this was critical to get the flag. So let's just go back now to our CyberTalents. So I'll just go on my submissions, and if the submission is just correct, then it means this is the end of the video. So you can see flag no mistakes with RIC. Alright, so this is Soko James representing KMU Cybersecurity Tutorials and the developer for the tool called Sokonalysis, which is the Cipher Toolkit built for all skill levels. Okay, hope you enjoyed the series. comment whatever thoughts or what challenge under cryptography I need to do. Remember, I'm also learning. Doesn't mean I know everything, but I'll try my very best to actually help you out.